I'm the development team manager in Velneo. And I would like to introduce you to our success story, bringing Velneo low code to the web thanks to WebAssembly. We will see what's Velneo and what was the challenge for us, why WebAssembly was the answer for this challenge, and how we integrate, thanks to the help of Qt framework, well, some technical insights about the processing with some demos, and what are the challenges now and the future for the platform once we are in WebAssembly. Velneo is one of the best companies to work in Spain. We have presence in more than 30 countries. You will see that most of them Spanish-speaking countries. This is our target, Spanish-speaking. So the platform is multi-language. And we help companies to create management applications, business applications for the companies to run using low code from Velneo. So Velneo is for ERPs, CRMs, supply chains, this kind of management. We don't make games with Velneo. We made applications for the companies. It's a PaaS solution. It means we have a platform as a solution in cloud. So you have tools to develop. You have tools for deploying. And for the deployment, and finally giving the final solution, the solution for the final user. We have a client-server architecture. It means that we can remotely develop applications, administrate the instances and the permissions, manage the database through a component remotely again, and finally execute the applications with interface using, again, a remote component, or serve the data using an API. Everything connecting with the server with a TCP by using a port given by the INA. That's the editor from Velneo Develop. In Velneo, everything is an object. The tables are objects. We have our own database. Fields are objects. Everything are objects. So we can help the programmer to connect very easily the information, the data between tables. And, well, indeed, indexes are objects. And also, processes are objects. So this way, we can help the programmer to easily connect information, program, without making nothing wrong, because it's very difficult, because everything is programmed with wizards and helping the programmer to make it good. Indeed, to program interface is just as simple to drop fields into the grids or the forms, and you are running your application, because Velneo, under everything, is connecting the interface with the database. You are seeing here how our application runs in a desktop. Okay? Velneo is multi-platform. It means you can develop using Windows and Mac OS, in Linux, and you can deploy in Windows, Mac OS, Linux, and Android and iOS. And now in web. That's one example of our application running in the web, like we were running until now in desktop. What was the challenge for us, and why WebAssembly? We started with a desktop application, okay? Our platform has 20 years of development. We developed our platform with C++, so the performance and the stability we have is very good. And the challenge was that we have separate builds for every operating system. This means you can imagine a great effort to maintain every build for every operating system. And finally, we have problems or inconsistencies in the final users across devices and across operating systems. It's a lot of work to maintain this. Qt framework helps us some because we can code once and deploy for every operating system. But again, well, the work, the running of the applications later in every operating system has its problems and its enough work. Web promise to build once and run everywhere. But the challenge is that we have a very good performance in desktop, so we need the same in web if we want to run our applications in the web. And well, we expect at the end for web to improve the user experience across devices and to be better than we have now at desktop. And why WebAssembly? We started a long time ago with a client using MPI-PI. It was running for a long time, but it was discontinued. It was our first test to run in web. Then we tried several solutions. Everything of that was discontinued. And then we found a tool, mscripten, that compiles for JavaScript. But when we tested it, the problem was the performance. It was not enough to substitute the performance we have at the desktop. And it appears WebAssembly. They promise to compile once and run everywhere. They promise near-native execution, performance in execution, and every mother browser to support the running of our applications if we use WebAssembly. How we integrate WebAssembly? We use, again, the tool mscripten. It lets us to compile from C++ to WebAssembly, to the bytecode of WebAssembly. We use now Qt framework. Has a version for WebAssembly that helps us with pre-built binaries and with the binary compatibility. But well, we started really compiling Qt for that at our start. Then we had to play a lot with flags and optimizations, not only for having an artifact and a smaller artifact for the first download, but for long sessions to be able to have the performance we need and the memory management we need to be able to run our applications, because they are so complex and, well, we have very good performance in desktop, so we will have to compare both and who wins, which wins. At the end, what we got, thanks to this integration, is that the Velneo's logic runs in web, runs in desktop the same very way. Programmers that program with Velneo has not to change anything to be running their applications, both in web, both in Velneo. That's important for us. And the other thing is, thanks to this integration, we were able to, please remember that we have client-server, so components from web were able to connect to the server the same way that desktop do. So we are able to interoperate between both environments. We started in this way to WebAssembly in this jump with our smaller component. It's the administrator, because it was the interface we knew better. And we tried to see if we were able to construct simple interfaces. And these are all lists and dialogues to edit the information. But another thing we tried here is the interaction. The user can interact with the objects, with the information we have here. And the other thing very important for us, because again, we are a client-server architecture, is that we were able to send the information to the server and receive the list of information. So this communication that we were doing with TCP. Next step, we see that it works for us, so it was the first step. The second step was to test the performance. The previously we see was very simple. Now we need to know if the performance is good enough. So we started to load more complex application with interface with an interface so more complex. Here, for example, we are seeing the tables from the server. We are loading this information. We load the records from a table. You are seeing 28,000 records loaded in milliseconds from the server. We can go through the information very easily. We can edit the records as fast as we are doing normally in desktop. So we can see that the performance was very similar to the one we have in the desktop. Indeed, we were able to execute the first processes in this environment. So yes, we got the performance from WebAssembly that we were looking for. And with more complex interfaces here, you can see that we open several views, and the component is able to run complex applications during long sessions. The last one was to run real applications. That's the one we saw previously. It's an ERPN example, and we are executing the application in the web browser. We are loading budgets from purchases. We can load thousands of records, edit the information, the records, the lines, with summaries, with a lot of tabs. So yes, at the end, we got very good performance with a very complex interface running real applications in WebAssembly, thanks to its performance. What about how we did it? Remember, we used mscripten to compile the Wasm module from C++. Qt framework helps us creating the files that we need to load the module inside the browser environment. Qt framework helps us to paint in the canvas of WebAssembly, let us to interact with, let the user interact with the information, with the interface, manage the events, and at the end, make the applications run and show the information. The communication between the component in web to the server is done by TCP connections from our side, but the mscripten tool helps us to convert the communication from TCP to WebSockets. So our server at this moment is listening both TCP connections and from the web is listening to the WebSockets. So we can interoperate from desktop components and at the same time run our applications or components from the web using the WebSockets. And what's about the deploy? How easily is the deploy? Well, it was very, very easy for us. Just dropping files in a bucket. For a time, we were using a runner with an Apache because there are some requirements by multi-thread. It requires some the use of shared array buffers and then the policies, of course. So it was at first the way we did it. But lately, CloudFront lets us to establish, to set these headers easily. So now we are testing right now the deploy, just dropping the files in a bucket with CloudFront. So at the end, very easy. And one thing that led us to be in a web browser is to use third social logging for our applications. Now our applications can receive the permissions to be executed thanks to this third social logging very easily because we are inside the browser. What about performance? How we got the performance? Because it's not only, well, first, the first download. Our packages are so big. I can say 40 megabytes for the first download. So we have to leverage, of course, in the cache, but we have reduced it using exploring different tools for compression. And thanks to Broadly, for example, we have reduced the package to 10 megabytes. So, well, it's more affordable for the first time. And of course, the cache helps for the next execution. So the first impression is so good. But we have to manage large data sets during our sessions. So we have to take careful management of the memory. And to be able to have this performance to work with many threads as possible. We have found that above 9, we experiment bad behaviors using more threads than 9. For example, Qt sets 4 by default. But, well, it's something we have to retest because we know that latest MScript versions and browser versions maybe can be able to let us to run with more threads. It's something we have to revisit. But for the moment, it's what we are using in our interfaces. Another thing we have to take care, it's the memory, because we are using Wasm 32 bits. So the thing was that we started in desktop with 32 bits, so we knew what are the limits. Our code was prepared to be running in 32 bits. Qt framework, again, helps us with binary compatibility between components with 32 and 64 bits. So, well, it's something just to take care. And also in JavaScript, usually it's recommended fixed memory. In our case, we can use dynamic memory easily. We start with a large amount, as you can see, because the applications are so complex and we work with very large data sets. But, well, we can let the memory growth if we need it, but without problems, indeed, in large sessions of working. Users can be hours using our application without any problem. Of course, taking into account that we have to manage these large data sets not to consume the limit that follows being 2 gigabytes until 64 bits be available for that. Well, just for the show to see how WebAssembly has very good performance. Here you can see how we download information, records with images. Now we have to download 600 lines of records. We can go through the database very fast, 11,000 records. We can go from the start of the grid to the end very easily. We can search in the database for the information. And here, for example, 2 million records, 2 million of lines, very fast. It's something that with regular applications is difficult to do. Indeed, when you have images and when you are editing the information, searching, well, you can see that the performance we get in the web browser, thanks to WebAssembly, is very, very, very good. And just for the show, I think, yes, just for the show, here we are loading 6 million of records with images. Take into account that everything is against a server in the cloud. Everything is with a server in cloud. This very example is using the TCP communication with WebSocket and loading this information from the server and showing in the interface as fast as we have been seeing. Another thing very important for us, it is just one slide, but it was the main work we have been doing for years, because most of our code base is synchronous. In desktop, we haven't need to be asynchronous in the code. So indeed, the interface is very connected to the database through communications to the server. So this is what the real work we have to do. We tried in the past with a Syncify tool that promised to help us to avoid to refactor the code, but we had very low performance. Overall, the problem was that the debugging was very, very difficult. We didn't control what was happening using a Syncify during the execution of our applications. So we have to drop it and just rewrite. And it's a project with 20 years of work, so 1 million of lines per year, 21 million of lines of code lines to review, to make them work asynchronously in a web browser. So it was a lot of work to make this running in the web. And many other adaptations, because we were used to the desktop, we were used to access directly to the disks to make anything, for the cache, for downloads from the application, for everything. So we had to use the tools that the browser gave us, local storage, file system API. We were used to access directly to the printer and print our reports. No, that's not an option, so we have to generate PDFs and let the user use the browser to print them. And just little things like access to the system settings. There are no system settings inside the browser, so we have to simulate their use to be the same as desktop. And well, again, Qt framework help us a little to simulate these things. What to tell about debugging? It's been said during this event. Lately, Qt helps with some tools to test overall, but well, just use console. One thing that helped us a lot this time was the use of disable exception catching. This way, we stop the application when there is something wrong, not following the session. And that was the way we were correcting the problems we were finding, but no magic solution. One thing that served a lot for us was selecting tier for the browser. We focus on Chrome to run our applications, our components, but we must say that well, everything works very smoothly in every of the browsers and indeed across the operating systems. Thought we focus in just one. Not only performance, we got thanks to that. Indeed, the interaction of the user with our applications, very easy. Rich interface, easily to transport to the web. We can paint anything we want. For the user, he's running the same way he's running in the desktop, so no change. And indeed, for our programmers, the programmers that program with Velneo, they have not to change anything to make it work here in the web. So it's fantastic for us, really. No more work, just to make your application run in the web. Well, so easy at the end. What was the benefits? What were the benefits at the end? Performance, we have seen, the information very fast to show to the user, rich interface, but we have simplified the development. We will be able to drop these separate builds we have now, Android and iOS, maybe soon to be avoided if we can run in mobiles. The deployment very easy, just drop the files. Imagine in desktop we follow having to install components, the problems with the permissions, with the administrators to install components are avoided very easily. Just the user connect to the web and run their application. We have another layer of security thanks to being executing in the web. Indeed, we are using the social logging very easily. And at the end, what we got is very good user experience across devices, across applications, across browsers. So very good. And the last one, maybe that we follow coding in C++. For us, this is a success of WebAssembly, that you can code in your favorite language, the one you know best. And we like C++, and we can follow enjoying programming using C++. The challenges for us for the future, testing and debugging, the complexity we have now. Threads and memory, we have to revisit to see if we can make use of more threads, for example, or better management of the memory. And finish the covering of the synchronous code that is pending yet. But, well, maybe more things for the future that will help us That's the last thing we are trying. We are testing our applications in web, in mobile. That's in an iOS, and we can run the same application. We can run now with a component for the iOS environment, running from the web, and again, with a very good performance, with very fast for the user, the same application he knows, very easy from the web. There are things to do to make it run, but well, we were able to do that, and we think that would be very good future for our application to be run in mobiles. Another thing we are expecting is the recently available 64 bits, maybe for a better memory management. Someone says that maybe performance is not as good as we would like. We would like something to avoid to refactor code. There are tools like Asyncify in the way, for example, JavaScript promise integration that maybe will help us to avoid to refactor every code we have. We'll see. Another thing are direct sockets. If you remember, where our server is listening now to web sockets and TCP sockets, both. So we could eliminate one and just be listening for TCP sockets. And well, Qt helps a lot, but maybe some more help could be affordable. Thank you.
Hello, great talk. Thank you very much.
Thank you.
I have a question, and what was the most trickiest part about porting this UI environment into the browser? Did you face an issue regarding rendering stuff, or it was more or less straightforward?
As we have said, the problem for us was the synchronous code at the end. It was the main work we had. When we started, there were problems with the memory. We have to play and with the threads, because it was supposed that no limit for threads. Our application in desktop used threads as much as possible. But when we were into the browser, it was not real. So we expect for the newer, latest versions of browsers to help us to improve in this way. But the main work was the synchronous code. The rest, Qt helped a lot. Qt framework let us, because we were used to have the multiple builds using Qt. So the jump to the web thanks to Qt helps a lot for us, at least, that we were used to use them.
Okay. Thank you.
Thank you, you too.
Hello. One thing is, you said 40 megabytes is a lot. 40 megabyte compressed or uncompressed?
40 was uncompressed.
Okay.
So we have to look for a tool that helps us to reduce this size and make the first impact to be as low as possible. So at the end, we got 10 for the biggest component. It's 10 megabytes, the size of the component, yes, the first download. Thank you.
And another, I'm sorry. Have you considered splitting the application in parts? I mean, I assume not all the code is needed, or only a limited part of the code is actually executed.
Well, we have components for administrating, for database management, and etc. But applications are so complex, and take into account that our customer is a programmer that can program whatever he wants, whatever she wants. So we have to be prepared for everything she needs to make their application run. So it's difficult to say we can just load things or not. It's so difficult. speeds of the internet and processors are every day going up. So now 10 megabytes are something, but in the future, maybe nothing. Thank you. Any question? So thank you very much. Any question, you can find me free to talk with me. Thank you.